Good day, everyone. So, I am Vanessa Ibanez, and together with my group mates, we will going to report to you the formation or the beginning of the Earth. We will going to tackle to you the formation of the Earth and how these processes have created or resulted this type of planet that we have. So, since we are going to tackle to you the beginning of the formation of the Earth, I have a questions to you. So, have you ever wondered how our Earth was created from just a dust or from just a disk of dust? So, in this topic, we will going to tackle about the Hadean Eon that will be presented by Group 4. So, from that picture on the screen, what do you observe or who do you think is that the person is? If you already have an idea, you can just comment your ideas who that person is. If that person that you are pertaining to is correct, which is the Greek god and ruler of the underworld named Hades, then you are correct. So, Hades is a Greek god of the underworld that can be seen with an overflowing of fire, which can be also related to the formation of the earth. So now, what do you think is the relationship of this Hades to the formation of the earth? We will going to know that later on. Hadean Eon is a geological eon that occurred between 4.6 to 4 billion years ago and named after Hades. So again, who is Hades? He is the Greek god of the underworld. It is because due to the extreme condition that prevailed on earth during this time. The earth was just full of fire that cannot just be inhabited by different of organisms because of the pressure that is earth containing. So, earth was almost unrecognizable as asteroids and comets repeatedly pelted earth. The earth we know is not the same as we thought today. That's what I have said earlier. Instead of a blue marble planet, it is a hellish form of body. So from the word itself, a hellish form of body, it means our earth 4.6 billion years ago is very different from the earth that we have now. From 4.6 to 4 billion years ago, the Hadean Eon is the first eon on earth. And its key events are, we will going to know the key events or the major events that happened in the Hadean Eon. So we have here the heat source. What do you think is the heat source of our planet? I think you can already see that on the screen. The next one is the magnetic field. The third one is the moon formation. I mean, there are still a lot of key events that happened on the formation of the earth, but these are the major events that must be discussed thoroughly by our group mates or by our group, enable for us to elaborate to you the major or the specific events that happened in the Hadean Eon. So okay, let's start with the heat source. Earth established a heat source with the sun. So as you can observe nowadays, the heat that we are getting is from the sun. It is because sun composes a huge heat that we can feel on the earth. Even if we are not that close to the sun, we can still feel the heat that the sun has given to us. So since the earth was the third planet that is nearest to the sun, we cannot feel the 100% of the heat that the sun can give to us. It is because we are not that near to the sun. If we are basically near to the sun, then probably earth would not be inhabitable, meaning there is no life. Earth couldn't compose a different types of molecules that can create lives. So the next one is the magnetic field. So convection currents produced a geodynamo. This was the first step for life to persist on Earth. As you can see from the picture, what do you think is the importance of magnetic field? So this magnetic field help us to keep us away from the toxic elements that the sun can give to us. When we say toxic elements, it means the toxic materials that the sun can give the earth, because those toxic materials can probably destroy the lives, not only the lives but the structures of the earth. And that way the magnetic field is acting like a shield to the earth, enable us to protect from that material that the sun can give to us. As you can see, that spiral color blue there, that is the magnetic field. And as you can see to the orange lines there, those are the materials or a heat source that the sun can give to us. It means that if magnetic field was not formed in the earth would probably be destroyed. So the next one is the moon formation. So the formation of our moon was key to stabilizing our climate. What I have read, the existence of moon has given us a good impact to stabilize the climate of our earth. From that, the formation of moon has given us a huge opportunity enabled for us to survive, because it would probably the adaptation that the humans can adapt in its environment. So as what you have observed on the picture that you have seen on the screen, so these are the key events. So as what I have presented to you earlier, those are the three major key events that happened on the planet Earth. So the first one is the Earth coalescing, the formation of water, the moon formation, the core accretion, the magnetic field, and the last one is the late bombardment stage. As what we have included to our PPT or to our presentation, we have a timeline enabled for us to determine the years of a certain element or a certain formation that helped Earth to be Earth that we know nowadays. So I will give the floor to the next reporter, Miss Justine Alvarado.
So in the year 4.6 billion years ago, our Earth didn't exist yet. So there was only a newly formed protosun and a ring of gas and dust. And that thing is called the accretion disk, which is incredibly beautiful in sight. So accretion disk is a disk-like flow of gas, plasma, dust, or particles around any astronomical object in which the material orbiting the gravitational field of the object loses energy or angular momentum as it slowly spirals inward. Okay, so now let's proceed to 4.5 billion years ago. So in 4.5 billion years ago, our planet was formed. Back then, it was about as far from inhabitable as possible the conditions on Earth, so we're really hellish instead of the usual landscapes. There was a sea of fire from molten rock. There were radioactive elements all around, and the surface temperature reached 4,700 degrees Celsius to 8,500 degrees Fahrenheit. So in 4.5 billion years ago, the planet Earth was formed. But then, in that year, dili siya ang usual na planet na to nga ginapuy-an karon. So before, it is really hellish, or it was a sea of fire from molten rock. So dili jud siya na-form ang planet Earth na naanay land, air, water, ana nga tayo. But then it is just like a sea of fire from molten rock.
So now we're going to discuss what are the events happened around 4.5 billion years ago. Around 4.5 billion years ago, Earth coalesced from a cloud of dust into a planet. The Big Bang created all matter in the universe. These include the sun, the planets in our solar system. The history of the universe is almost unfathomable. This explains that the universe is an ever-expanding, chaotic, and mysterious place. So from the Big Bang to the formation of our solar system, we have been trying to understand more about it ever since. From a cloud of dust, gravity molded our solar system. the terrestrial planets were positioned closer to the Sun. After Mars, these are the gas outer planets. So how gravity sculpted the Earth? We all know that all matter on Earth has gravity. In other words, the gravitational force is always at work, even sculpting planets and the universe, as well as why rocks fall downhill, because gravity is always at work. So the formation of the Earth is when the solar system settled into its current layout about 4.5 billion years ago. Earth formed when gravity pulled swirling gas and dust into become the third planet from the Sun. Like its fellow terrestrial planets, Earth has a central core, a rocky mantle, and a solid crust. Heating had very important consequences for Earth's structure. As Earth grew, as what you have seen in the picture, it collected a mixture of silicate mineral grains as well as iron and nickel. These materials were scattered throughout Earth. That changed when Earth began to heat up. It got so hot and that both the silicate minerals and the metals melted. The metal melt much denser than the silicate mineral melt. So the metal melt sank to Earth's center to become its core, and the silicate melt rose upward to become Earth's crust and mantle. In other words, Earth unmixed itself. The separation of silicate minerals and metals into a rocky outer layer and a metallic core respectively is called differentiation. Gravity has since pulled Earth into an almost spherical shape with a radius of 6,371 km and a circumference of about 40,000 km. However, it is not a perfect sphere, as the Earth's rotation causes an equatorial bulge so that the Earth's circumference is now 21 km wider at the equator than its pole to pole. Thus, it is technically an oblate spheroid.
And now let us proceed to the planet formation and the core accretion theory. The core accretion theory describes the creation of our planet and solar system, from the inner terrestrial planets to the outer gaseous planets. It illustrates how planets become multi-layered. Today, we're going to go through the core accretion theory steps of how to build a real planet like Earth. Our solar system went through a series of events that transformed it into what it is today. First is rotating cloud of dust. For our solar system, the core accretion theory starts with a rotating cloud of dust. Next, it accumulates pooling in 99.8% of matter. Eventually, this becomes our sun at the center of the solar system. Second is the solar winds. Solar winds swept in hydrogen and helium atoms that were closer to the sun because they were smaller in size. But the sun wasn't able to pull in heavier elements. Why? It is because of their heavier mass. Third is coalescence. Heavier elements spiraled and gelled together into planets of their own. Earth and the other terrestrial planets coalesce to form spheres. The heaviest material, like zinc and iron, sank to form an inner core. Finally, lighter material remained on top, meshing together to create a crust. Our solar system is a planetary system that includes a central star of the sun and all the natural space objects orbiting the sun. At the center of the solar system is the sun, which accounts for 99.86% of the total mass. The planets closest to the sun are densest, which includes Mercury, Venus, Earth, and Mars. They are terrestrial planets that are composed of heavier materials like iron, silicon, and aluminum. Finally, the gaseous planets are made of lighter materials such as hydrogen, helium, and methane. These planets reside on the exterior of the solar system, including the Saturn, Jupiter, Uranus, and Neptune. Now, we have learned that the core accretion theory is a theory that explains the formation of the Earth. It draws on theories on planetary formation, specifically the role that accretion plays in planet formation.
In this part of discussion, we will tackle about the time of 4.4 and 4.3 billion years ago. So first is the earliest remnants of Earth's crust. So about 4.4 billion years ago, durable zircon grains were formed within sedimentary rocks in Western Australia, providing evidence of some of the oldest crust on Earth. So 4.4 billion years ago, tiny zircon grains were formed within sedimentary rocks of the Jack Hills in Western Australia. These zircon grains are believed to be the remnants of some of the oldest crust on Earth. So this is the sample evidence that scientists have found zircons that date to almost 4.4 billion years ago. These zircon grains indicate the existence of continental crust on Earth billion years ago. So the zircon grains are durable minerals that can withstand geological processes and provide important clues about the early Earth's composition and history. The discovery of these zircon grains in the Jack Hills provide evidence of the existence of continental crust on Earth billions of years ago. So that's the earliest remnants of Earth's crust. And now we are here in the time of intense meteorite bombardment on the moon. About 4.3 billion years ago, research based on lunar rock samples collected during the Apollo 16 mission conducted by NASA suggests evidence of intense meteorite bombardment on the moon. So we have class 3A, which refers to the area sampled from the anorthosite rock code 60016-196. So the rock shown here was brought back during the Apollo 16 mission. So flight date was on April 27, 1972. So credit to AJU. This period of intense meteorite impacts is known as the Late Heavy Bombardment and is thought to have affected not only the moon but also the inner solar system bodies. So the evidence of meteorite impacts on the moon's surface as revealed by the Apollo 16 lunar rock samples indicates a period of churning and upheaval of rocks to the lunar surface during this time. So therefore, earliest remnants of Earth's crust and intense meteorite bombardment on the moon. Both of these evidence provide important insights into the early history and evolution of both Earth and the moon. The discovery of zircon grains in the Jack Hills provide evidence of the Earth's ancient continental crust, while the evidence of meteorite bombardment on the moon sheds light on the intense impacts that shape its early geological history. The credit to NASA indicates that the information is likely based on scientific research conducted by NASA as part of their lunar exploration missions.
Good day everyone, I am Princess Oliveros and now let's learn about what happened in 4.2 billion years ago and 4.1 billion years ago in Hadean Eon. 4.1 billion years ago, Earth's magnetic field formed. We all know that Earth's magnetic field protects our planet from cosmic radiation and from charged particles emitted by our sun. But have you ever wondered what causes magnetic field to form? Magnetic field form because of electric current. But how? So, the outer core of the Earth is a liquid metal, mainly iron. The fluid motion in the outer core generates electric current. The motion of the current is sustained by convection and is driven by buoyancy. So when Earth spins on its axis, it makes electric current to form a magnetic field that extends around the planet. And that's what happened 4.2 billion years ago in Hadean Eon. So now let's proceed to 4.1 billion years ago. Some scientists suggest that in 4.1 billion years ago, at this time, there were already water on Earth despite its high temperature, and the late heavy bombardment hit the Earth with a huge number of asteroids, which helps the Earth to be covered with water. But what is the late heavy bombardment? Late heavy bombardment refers to impact events that occurred after stabilization of the planet. The entire inner solar system suffered through an intense spike in asteroids. But first, scientists believe that the comets and meteorites are the ones who help cover the Earth with water. Comets are frozen leftovers from the formation of the solar system, and it was composed of dust, rocks, and ices. They believe that the water came from the comets when it melts, but they need to support their claim. So what they do is they send spacecraft to test the water on Earth and in the comets. But how come the water on Earth is different compared to other planets and celestial bodies? As we know, hydrogen is a part of water molecule, but sometimes hydrogen receives additional neutron. When it does, hydrogen is called heavy hydrogen or deuterium. In the Earth, the deuterium-hydrogen ratio or the DH ratio of water is 1.55 parts per million compared to Mars, which is 330 ppm. As we can see, it is different. Look at this graph. As you can see, there is a match in Hartley Comet. In 2010, scientists sent a spacecraft to test the DH ratio of Hartley Comet, and they saw that it is matched in Earth's DH ratio. And then, they believe that Jupiter family comets brings water to Earth. But in 2014, they decided to send the famous Rosetta spacecraft to Churyumov-Gerasimenko comet, which is a part of Jupiter family comets, and found out that it is not much. Since comets are far from the DH ratio of Earth's, they decided to try asteroids, and then they found out that the asteroid has mostly the closest DH ratio of Earth's water. They then concluded that the asteroids are the ones who fill water on Earth, not the comets or meteorites.
So good afternoon everyone, my name is Michelle F. Guzman, and now we will be tackling on what happened during 4.0 billion years ago. So in 4.0 billion years ago, the first Earth crust was formed, largely covered by a vast salty ocean containing soluble ferrous iron. So asteroids brought water and small organic molecules due to the late heavy bombardment. So makapangutana tanong na ngano di ay kuan nganong ang first crust is na covered siya sa water. So around 4 billion years ago, the Hadean Eon, the Earth was still in the process forming the undergoing intense geological activity. So at this time, the Earth's surface was constantly bombarded by asteroids and comets. So because of the asteroids and comets, it caused a widespread volcanic activity and the formation of large impact craters. So during 4 billion years ago, the Earth's first ocean began to form from water vapor released by volcanic activity and from comets and asteroids that contained water. So as the Earth cooled and solidified, the first crust formed, so which was likely composed of basaltic rocks that were formed by volcanic activity. So this crust would have been covered by the early ocean, which were likely very different from the oceans we know today. So, with a different composition and temperature. So, nga di ay ang asteroids, comets, o mga meteors is one of the reason anong natabunan ang first crust sa una. It is because comets are a mixture of dust and ice with some or most of that ice being frozen water. Seemingly, dry meteors can contain small but measurable amounts of water, usually trapped in their mineral structure. So during heavy bombardment periods later in Earth's history, its cold surface was pummeled by comets and meteorites, which could be why so much water exists above the ground.
So the late heavy bombardment is characterized by a sudden increase in the number of impact craters on the moon and other inner solar system bodies. Due to the impact of the heavy bombardment, volcanic activity have occurred. The late heavy bombardment caused a huge scene on the formation of the Earth. It have resulted a lot of craters on the Earth, resulting for a volcanic activity that arises on the planet Earth. If there is a volcanic activity, of course, there's also a chemical elements that have occurred, such as the water. Another theory that being presented to us by different scientists was the volcanic activity also causes why Earth are surrounded by water nowadays.
So now let's proceed to an overview of the Hadean Eon. So in Hadean Eon, we obtain the heat source, magnetic field, and the formation of the moon. So in Hadean Eon, there are no fossil records because the temperature is too high to sustain life. So anong walay fossil records ang during the Hadean Eon? So it is because ang Hadean Eon ginatawag siya og kanabitang living hell. So dili jud siya ka-sustain sa ecosystem of life kay parte jud siya kainit. The picture presented is the oldest dated zircon crystals. So now let's proceed. So in Hadean Eon, it is almost unrecognized. Heat flow was nearly 3 times as high as it today from planetary accretion. So like what I've said earlier, ang Hadean Eon is pretty jud siya kainit, no, maong dili siya ka sustain of life. So that's all my part. Thank you for listening.
As you have observed, these are the whole timeline of the Hadean Eon, which was started from the 4.6 billion years ago, or GA, the giga-annum or billion years ago, to 4.0 giga-annum. In 4.6 giga-annum, the accretion disk or the protosun in the ring of gas was created. In the 4.54 billion years ago, the sea of fire from molten rocks was observed and was created. In the 4.52 billion years ago, Earth coalesced from cloud of dust. In the 4.4 billion years ago, the earliest remnants of the Earth's crust was created. And the 4.3 billion years ago, the moon's appearance, which is the meteor bombardment on the Earth, have happened, resulted different types of activities that may include different processes enabled to have the Earth to be stabilized. So in the 4.2 billion years ago, the magnetic field was created, which was protected the Earth from the sun to enable for the Earth to sustain life with the help of the magnetic field. And 4.1 billion years ago, the late bombardment happened. So in this time, there are a lot of volcanic activities that happened that resulted in the formation of water surface. In the 4.0 billion years ago, the first crust was formed. That would be all. And if you have a follow-up questions, you can PM us, enable for us to assist you with your questions and give you some answers. Thank you for listening.